Hello everyone. In this lecture, we will discuss the mean and variance of a discrete type random variable. Now recalling a discrete type random variable x, right? It includes finitely many sample points. It includes finitely many sample points x1, x2, so on up to xn. So x is a random variable here. X is a random variable here. Now what is f? Now this random variable associated with the probability function. In this case, we usually call it probability mass function. Also, or it is also known as probability density function. Right. Now, what is a probability distribution function? Here, capital F of x is the probability distribution. What does it mean? It means f of x at small x means it is probability, sum of the probability up to x, right? That's why it is also called cumulative distribution function. Cumulative distribution function, CDF, or simply PDF, capital PDF, right? Probability distribution function, probability distribution function, whatever it may be. So now, what does it mean? If we are talking about the cumulative distribution of x1 means it is only f1. The moment we are talking about x2, the distribution of x2, x is equal to x2, it will be probability up to x2 will add f1 plus f2, and similarly it will be summation of fi. You take it j is equal to 1 to I, up to I it is I up to I, and similarly it is a summation of fj from j is equal to 1 to here n, right? Now the moment there are some cases where the sample points extends up to infinite, we say that n tends to infinite. For example, as I have told you, tossing a coin until head turns off. In this case, you may get a head in first trial. Suppose you may get a head here. The random variable here is you may get a head here. You may get first tail, then you may get a head. First two cases you may get tail, then head, and it is continue in this way. You get suppose tail up to n-1, it is tail then head. If not, the experiment is continued. So here what is the probability here? It is for head it is half, for head and tail it is half into half, 1 by 2 square, it is 1 by 2 cube, continues on, it is 1 by 2 to the power n, and it is extended. So this is a case of a discrete random variable, right? Even if the sample points extends to infinite, but this is having a pattern, they are distinguishable one after another. So this is a case of discrete random variable, and also we can confirm this is a random variable because if you add them, then it is your 1. It is your half into 1 plus half square. We did it earlier. So on. So this is a GP series, or it is the expansion of 1 by 1 minus x. So this is equal to 1. So it is confirmed that it is a discrete type distribution. Now what will be the distribution function of this? Likewise, your f will be here. It is your f1. It is your f1 plus f2, and similarly it is summation of fj. J varies from 1 to I. Similarly, it is your summation of fj. J varies from 1 to n, and similarly it can be extended to this case, right? So this is a continuous random variable, and this is a discrete random variable with n tending to infinite, and this is a discrete random variable with finite number of sample points. Now coming to an example in this case, suppose we roll a die, right? Rolling a die. Let the random variable x, the number turns off. So in a die, in a die. It may be 1, 2, 3, 4, 5 and 6. Now here probability, corresponding probability, getting 1, the chance is 1 by 6. Similarly 1 by 6, similarly 1 by 6, similarly 1 by 6. So here all are equally likely 1 by 6. If we talk about what is the distribution, right? So the distribution here is 1 by 6. Here the distribution is this plus this is 2 by 6. Likewise, sum of the first 3 is 3 by 6. It is 4 by 6. It is 5 by 6. It is 6 by 6. So this is your corresponding distribution function. So I can say it what? It is f of x is equal to 3. Means probability of x up to 3. Right? Means it is your f1 plus f2 plus f3. In this way, the distribution function you will get. Clear? So basically, the discrete random variable means it includes countably many points and which are distinguishable one after another. Okay. Now coming to the mathematical expectation. Coming to the mathematical expectation or mean mathematical expectation. Mathematical expectation. Let x be a discrete random variable associated with probability mass function fi. Right? Let phi x be a function of x. Then we say the expectation of phi x. Right? The expectation of phi x or mathematical expectation of phi x. It will be summation of xi multiplied with individual associated probability and it is finally added together. As many as, if I start from 1, then 1, maximum number is n, then n. As many as n, we will write that. So this is xi fi. This is your xi fi. This is also this expectation of phi x. We call it expectation of phi x or expectation of phi x or mathematical expectation of phi x, or we can say expected value of phi of x. Now coming to the mean and moments. So the moment when phi x is equal to, when phi of x is your random variable x, right, then this expectation of x is your mu is your mean. So what is mean now? So thus we can say the mean of the random variable x or expectation of x is summation of xi f xi. So earlier it was phi of x. Earlier it was phi of xi. Sorry, it was phi of xi f xi. Earlier it was phi of xi f xi because we are finding the moment of phi x. So here you have xi into fxi. It is xi into fxi. Likewise, so this mu here is called the mean of the random variable x. Likewise, if I ask you what is the rth moment, if phi x is replaced by x minus a to the power r, where a is a specified number specified real number. It is a specified real number. R is a non-negative integer. Non-negative integer. Then your expectation of x minus a to the power r. It is called the rth moment. So in notation you can say mu ra. Right? What will happen to this? Likewise, it is summation of, it was x, so it is xi. Earlier it was phi x, so phi xi. So here likewise xi minus a to the power r f of xi. F of xi. So this is here xi. Here this is called the rth moment of the random variable x about here a. Then what will happen at this moment? Also we can say what is here mu r of 0. If I ask you what is mu 0 of a, if I ask you mu 0 of a, then what will happen? At this moment we can have some remark. It is summation of xi minus a to the power 0 fxi. So it will be summation of fxi is here 1. The moment I will ask what is mu 1 of a, so this will be summation of xi minus a into fxi. So if you split it, summation xi fxi minus a can be taken out, summation of fxi. So this is your mu minus a into 1. So this is mu minus a. Next coming to the rth central moment. Next coming to the rth central moment. Rth central moment. The moment phi x is replaced by x minus mu to the power r, or I can say this a is replaced by mu here. Mu is here mean. Then it leads to the rth central moment. Thus we can say expectation of x minus mu to the power r will be equal to summation of xi minus mu to the power r fxi. So as many as number of sample points we will write that. So in notational sake you can write mu r or mu r of mu. So it is better to write mu r, means the rth central moment. Likewise, if I ask what is your mu 0, if I ask now what is your mu 0, it will be summation of xi minus mu to the power 0 fxi. So this is 1 into fxi. This is equal to your 1. If I ask you what is your mu 1, mu 1 will be summation of xi minus mu to the power 1 into fxi. So this is summation of xi fi minus mu summation of fi. So this is mu minus mu is equal to your 0. So this is your rth central moment. So I can tell you some properties over here. If I tell you what are the properties. Expectation, properties of expectation. Expectation of x, as you know, is summation of xi fi. If I ask you what is expectation of x square, likewise it will be x square fi. If I ask you expectation of constant here, it is your constant. If I ask expectation of ax plus by, it will be a expectation of x plus b expectation of y. Likewise, if I ask you what is the expectation of mu, mu itself is constant, this will be also mu. Now coming to the variance. The second central moment is called the variance. The second central moment is known as the variance. That means I can say here mu2 will be expectation of x minus mu square. So what will be that? It is summation of xi minus mu whole square fxi, right? So this variance of x is denoted by sigma square, or it is denoted by varx, right? So this is the second central moment. So this is 2 here. So this is the second central moment. So the second central moment is your variance. Now we can correlate this mean and variance. So what is the relation between mean and variance? Here sigma square is expectation of x square minus mu square. We can prove it. What is your sigma square? Sigma square is expectation of xi minus mu whole square. So you can write it expectation of xi square minus 2xi mu plus mu square. Now the properties of expectation you apply here. So this is your expectation of xi square minus, you write it better, you write x. The moment we'll split it in summation form, then we'll write xi. So this is x square, this is x square. So expectation of x square minus twice mu being constant taken out, expectation of x plus expectation of mu square. So this is expectation of x square minus twice mu, expectation of mu x is mu, plus expectation of constant is constant. So this is equal to expectation of x square minus, this is twice mu square plus mu square, right? Or we may write it expectation of x square minus expectation square x. So this is the relation between mean and variance. And this relation will also hold for continuous type random variable. Coming to an example, suppose a fair coin is tossed 3 times. X denotes the number of heads. The random variable x is the number of heads. You are asked to find the distribution of x and mean and variance. Now coming to the solution. So what will be the sample space here? In tossing a coin 3 times, the sample space is like this. We may get head, and head. We may get 2 head and 1 tail, HHT or HTH or THH. Likewise, we may get 2 tail and 1 head, tail, head, tail, head, tail, or we may get all 3 tails, right? So now we can classify it. This is your x is equal to 3. We are getting 3 heads because x denotes the number of heads. Now this is the category of x is equal to 2. And for this, we have x is equal to how many heads here? 1. And for this, we have x is equal to 3. So what is the random variable here? The random variable is 1, 2, and 3. Also, we may write it here. Sorry, so it is how many heads here? Sorry, it is here 0 heads, no heads. So the random variable will be here 0, 1, 2, and 3. The random variable will be here 0, 1, 2, 3. This is your random variable. So now what is find the distribution of x. So what will be the distribution of x? So the distribution of x will be here. The distribution of x is here 0, 1, 2, 3. So the random variable together with the probability function. So here all tails means 1 by 8. The sample space here is the sample space cardinality of the sample space is 8. The event here is only 1. So this is 1 by 8. Likewise here 3 sample points here. Here also 3 sample points here. And getting all heads is 1. So it is 1 by 8. Now whether it is correct or not, you can get it confirmed by summation of fi. It is 1 plus 3 plus 3 plus 1. 8 by 8 is 1. So it is okay of writing this distribution. Now this is a probability distribution. This is the probability distribution as asked. Probability distribution. Now you have to find the mean and variance. For finding the mean, you can extend it. What is x into f? Because summation f, what is your mu? Mu is summation of xf, is not it? What is sigma square? It is your expectation of x square minus mu square. Expectation x square, how you will get it? It is summation of x square f. So you find xf. Xf is 0. It is 3 by 8. It is 3 into 2. 6 by 8. It is 3 by 8. Right. And what is your x square f? You multiply it. It is 0 square into 1 by 8, 0. 1 square into 3 by 8. It is 2 square, 4 into 3, 12 by 8. It is 3 square. It is 9 by 8, 9 by 8. So now so what is your mean now? So its mean is here. Your mean is given by summation of xf. If you add it together, this sum will give you, this is 3 plus 6 plus 3, 12 by 8. 12 by 8 is 1.5, is 1.5. And what is your summation of x square f? And if you find this is x square f minus mu square. If you add it, it is 12 plus 9 plus 3, 24 by 8. It is 3 minus 1.5 minus 1.5 all square. So it will be here 3 minus 2.25 is 0.75. Alternatively, if you want to find your sigma square, summation of xi minus mu whole square, you can get it. So first one is 0 minus 1.5 square, then second one is 1 minus 1.5 square, and so on. You can continue 3 minus 1.5 all square. The same thing you will get it again 0.75. But this is a easy approach now. Then coming to another example, you are given a distribution like this, and you are asked to find what is mu, what is expectation of x square, and what is sigma square. Now coming to mu, it is summation of xi fi. If you add it, it is k into, this is k, this is 4k, means this is k into 1 plus 2 square, this is 3 square, so on up to n square. Then it is k into 1 square plus 2 square plus up to n square is n into n plus 1 into 2n plus 1 divided by here 6. Right. So this is your mu. But prior to this mu, we have to know what is the value of this k. So first you find the value of this k. So for finding the value of this k, first we find k. For finding k, you have summation of fi is equal to 1. So you have k plus 2k up to nk. So that means k into 1 plus 2 plus up to n is here 1. So this implies k 1 plus 2 up to n is n into n plus 1 divided by 2 is here 1. So what is your k? It is 2 by n into n plus 1. So what is your mu now? So now your mu is equal to, it is 2 by n into n plus 1 into n into n plus 1 into 2n plus 1 divided by 6. So n plus 1, it is cancelled, it is 3 cancelled. So it is here 2n plus 1 divided by your 3. Likewise, what is your sigma square? It is expectation of x square minus mu square. So your summation of xi square into fi. Then what you will get? So this will, so if you simplify it, you will get expectation of x square will be this. So now 1q plus 2q plus up to nq, and it is n into n plus 1 by 2 whole square minus this. You simplify it to get it. So this is the variance of this. So the distribution of this function is this. With the value of k, you substitute the value of k here and subtract it, simplify, you will get it. Now coming to another example. What is the expected daily profit if a store sells air conditioner per day? And the probability is like this. Selling 10 air conditioner is 0.1, 11 number of air conditioner is like this. So, and the profit per air conditioner is $55, right? So this is a discrete case. You see, so what is the distribution table here? So 10 air conditioner, probability 0.1, 11.3, 12.4, 13.2. You find the average profit, and the profit per air conditioner is this much. So now what is x into f? It is 10 into 0.1 is 1. It is 11 into 0.3, 3.3. It is 12 into 0.4 or 0.8. 13 into 0.2, 2.6, right? Now if you add it, what is the mean average profit? Mean is summation of xi fi. If you add it together, then the sum will be 11.7, right? And the profit per air conditioner, it is per air conditioner is this, right? And the average number of selling is this much. So what is the profit now? The profit is 11.7 into 55. This is equal to, in dollar, it is 643.5. So the profit will be this much. Now just one more example we will solve. The last example we will solve it here. If x is a random variable and k is a constant, then prove this 1, 2, 3 and 4. Coming to the proof of 1, expectation of kx. Also earlier I have told you the properties. It is summation of k xi fxi. You can take k out. It is summation of xi fi. This is nothing but your expectation of x. So this is your k, your expectation of x. So first one is our. Coming to the proof of second, expectation of x plus k. So you split it out in the properties here, or it is summation of xi plus k fi. The definition of expectation. So split it, xi fi plus summation of k fi. You may take outside your k, it is your expectation of x and plus k taken out is summation of fi. It is expectation of x plus k into 1. This is expectation of x plus k. Coming to the proof of 3, variance of kx. Now it is proof 3. Variance of kx. So this will be here summation of k xi minus expectation of kx whole square fxi. Now expectation of kx is k expectation of x. So this is equal to, so here this is equal to your expectation of kx your expectation of kx is k taken out expectation of x. Now you split it. So k taken common and it is whole square outside. So it is your k square. Your xi minus expectation of x whole square fxi. So is it not your variance of, so this is k square into simply variance of your x, is not it? So it was asked, it was k square into variance of x. Now coming to the last example, variance of x plus k. The formula is summation of xi plus k minus, because what is sigma square? It is expectation of x minus mu whole square. So here variance of this, so this minus mu is this whole square of xi. Now expectation of x plus k, split it earlier as we did. It is expectation of x and separate it. So now this k and k cancelled. So this is summation of, your square is here, summation of xi minus expectation of x whole square fxi. So it is simply variance of x, is not it? So this is simply your variance. So it is simply your variance of x, is not it? So it is proved. So this is all about the mean of a discrete type random variable.